Okay, in this lecture we will see the condenser, the different types of condenser. So condenser is nothing but just a heat exchanger in which heat transfer takes place from high temperature vapor to low temperature air or water, which is used as cooling medium. Heat transfer takes place from high temperature vapor to low temperature air or water, which is used as cooling medium. So there are basically three types of condensers. First is air cooled condenser, second is water cooled, and third is evaporative type of condenser. We will discuss these all things one by one. Okay, so this is a air cooled condenser. First let's see there are two types, natural convection and forced convection. Okay, so this is a natural convection air cooled condenser, where you can see that refrigerant is coming from compressor and going to the expansion valve, and this is just tubing of refrigerant which is coming like this, and there is no fan for cooling or for convection purpose. This is the natural convection convection condenser. But this you can see the other case that the refrigerant, high temperature refrigerant vapor come from the compressor and goes to the condenser. Okay, this is a condenser, and it comes back to this side, and there is a fan which helps to cool faster, and this is a forced convection. Natural convection air cooled condenser uses large condensing surface area, and this is basically used in domestic refrigerator. You have been looking at your refrigerator, that the back side of the refrigerator has the tubings arrangement that is called the condenser, which is a natural type of condenser. And this type of natural convection air condensers are basically used in the capacity of up to 3 ton. Merits of air cooled condenser, you can see that these are cheap due to simple construction. Okay, low maintenance cost, just cleaning of pipe tubings are required, no piping work involved, negligible corrosion effect since no water which causes corrosion, so it is a free from water, so less chances of corrosion is there. Disposal of air is easier in compared to disposal of water, and high flexibility. So the demerits of air cooled condenser is that their use is restricted to small capacity refrigerator units. Okay, and the rate of heat transfer is low, and distribution air on condenser surface area is uneven. Increase in ambient temperature causes reduction in the capacity to the condenser. Okay, ambient temperature condition reduces the capacity of the condenser. So these are the demerits. Now second type of condenser is water cooled condensers. The water cooled condenser are basically three types. See, this is a cell and tube condenser. First is cell and tube condenser, second is cell and coil condenser, third is double pipe condenser. Okay, so let's discuss one by one. Cell and tube type condenser. In this type condenser, we will see its diagram first. Okay, so this is a horizontal cell and tube water cooled condenser. In this condenser you can see that this is the high temperature high pressure vapor refrigerant vapor which is coming from compressor and passing through these horizontal tubes. Okay, these are the tubes and coming from here, and the water inlet, this is the water inlet where cool water comes and passes through these tubes of refrigerant and goes back to their source area. These are the hot water becomes hot here. So this is a cell, this entire is, these are the tubes, and this is just a normal diagram of cell and tube water cooled condenser. So the advantage of horizontal cell and tube condenser is that the coolest water enters at the top of the condenser and makes several passage before leaving at the top. The result is great increase in the water temperature. So basically they are saying that it is good in cell and tube type condenser to cool it is effective in cooling the refrigerant. And the disadvantage, let's see the disadvantage, that they must be taken out of service for cleaning. The cell and tube may require the cleaning because there may be chances of scale formation since water is used, and there may be also restriction of due to friction. Water pumping friction head may be high, and frequent cleaning may be needed to maintain efficiency. Okay, now let's see the cell and coil condenser. Okay, this is a cell and coil type of condenser in which you can see that refrigerant from vapor from compressor at high temperature and pressure enters through this cell, and this is a water pipe which is in coil shape. These are the water coil, and the cool water enters from here, from top to bottom, and leaves from here, and the refrigerant which comes to contact with this cooling coil of water, it becomes condensed, and it can be taken from here to evaporator. So these are the condensed liquid refrigerant. This type of cell and coil type condenser is preferred where clean water is available because of its coil cannot be cleaned easily. Okay, so we can use only clean water for this type of condenser, and it can be cleaned by circulating acids or the chemical through them. This may be done on continuous basis by adding a small amount of chemical to the water while the unit is in operation. Okay, you can add a small amount of chemical or acids to water to clean the scale formation due to hardness of water or due to any impurity in water. Small impurity, since we use clean water, but there may be chances for in long operation that there may be dirt inside the tube, so you can use acids or chemicals to clean the water during operation. Now let's see the double pipe water cooled condenser. This is a double pipe water condenser in which you can see that water is coming from here and passing through this pipe, and the refrigerant, and this is the exit point of water, and refrigerant vapor comes from compressor, and it comes to like this, and these are double pipe or concentric pipe. So it comes here, and it becomes liquid here, and this type of is used for ammonia refrigerant, and ammonia is basically used inside the steel pipe. It is not used in copper pipe. So the diameter of this water pipe is around 30 mm, and the refrigerant ammonia is around 50 mm. Okay, the disadvantage of double pipe condenser is that though the counterflow principle available with the double pipe condenser makes good use of the water available. Okay, there you can see that the flow was the counterflow. The large amount of joints and connections needed in large installations. Okay, joints and connections are increased chances of leaks. These condensers are difficult to clean and do not provide enough space for separation of gas and liquid. Okay, this becomes tough for cleaning because the one tube is inside the another tube, and if there is a chances of leakage, then that is so harmful because we are using ammonia refrigerant, so that is a undesirable thing. So these are the disadvantage. Okay, and the last one is the evaporative condenser. Okay, this is a evaporative condenser. In this condenser you can see that this is the water below the evaporative tank. This is a pump which is pumping this water from here to this spray nozzles, and these are the refrigerant, liquid refrigerant. This is a vapor, refrigerant vapor, which is coming from the compressor, and this is it. In this condition it is in vapor state, and the pressure is high, temperature is high, so it passes through these tubes, and there is a spray of water over the tubes, and you can see that air is passing from here. This air is coming, and this is going upward direction. In upward direction there is cooling of this refrigerant through evaporation method. Okay, the refrigerant is delivering its okay, so heat is delivered to the water, and water gets evaporized and takes the heat from the refrigerant, and these are the eliminator which prevents the water droplet from escaping from this exhaust fan. The water gets condensed here, water droplet condensed here and come back to this area. Okay, so this is the basic operation of evaporative cooled condenser. Evaporative condensers are used in for industrial purposes, and these are generally used in up to 100-ton capacity plant, and due to evaporation of water, if there is not enough supply of water from the outside, then there will be chances of salt formation, and that may cause the scale problem. So it is necessary to provide sufficient water to the pump and the tank, and the maintenance of this evaporative condenser is by providing the proper lubrication to the fan, shaft and motor bearing should be properly lubricated and checked periodically for tension and wear and tear, and pump bearing should be lubricated properly. Now let's discuss the cooling tower. Cooling tower works on the principle similar to the evaporative condenser, and the rate of evaporation depends basically on the amount of water surface exposed, the time of exposure. Okay, when it is exposing in morning, afternoon or evening or night, that is also depends upon the evaporation, rate of evaporation depends, and the relative humidity of the air passing over the water droplets formed in cooling tower, the rate of relative humidity of air and difference between the inlet air and WBT and water inlet temperature, the direction of air flow relative to water. There are different types of cooling tower: natural draft cooling tower, mechanical draft cooling tower, induced draft cooling tower, forced draft cooling tower. So let's see the natural draft cooling tower. This is the diagram of natural draft cooling tower. Okay, you can see that this is a natural draft cooling tower, and there is a flow of no flow of air by any fan media. It is totally based on natural air. So the water sprays are hot water comes here through the top portion, and the sprays are here fitted, and the cold water goes out. Okay, cooling tower is for cooling the hot water. Okay, its purpose is for cooling the hot water comes from the condenser. Okay, so this is a natural draft cooling tower, and the main drawback of this system is that it requires large enough space, which is not available easily in some places, but you can place this cooling tower on the roof of the building. This is induced draft cooling tower. In this type of cooling tower, everything is same except there is a fan. The exhaust fan is here driven by this motor, and the air is coming from here, and this exhaust fan is using to make air go out, and the only thing is that the difference is that the fan is used in this type of system. In forced draft cooling tower, you see that this is a fan fitted bottom side, and it is a air is coming from here, this fan to and going upward direction, water from the top portion, and it is coming out, the liquid water is coming out here, and these are the eliminators, spray eliminators, which protect the water droplet coming out from going out, and basically what happens here, that the air which is cooler than which has a lower temperature than the warm water of top portion, the air takes heat energy from the water and becomes hot, and the water vapor gives its latent heat to the air, so the water vapor gets condensed and settle down here. So this is the only working principle of this cooling tower. Advantage of this type of cooling tower is that it requires less space, and these are the more efficient than the natural draft cooling tower. At last, this is a hyperbolic cooling tower, which is basically 340 to 260 feet height in diameter, and you can see the shape. This is in hyperbolic shape. This is a cell. It is basically used for large thermal power plant. Okay, so outstanding advantage of hyperbolic tower are that it can operate even at zero wind conditions. Okay, there is no moving component required for inducing the draft. Power which is required for operation is only for pumping. Because of its height, ground fogging and recirculation of warm moist vapor do not occur. Okay, atmospheric air for direct water cooling is induced. These are the type of cooling tower which is widely used in thermal power plant like NTPC. Okay, now let's see some questions. So first one is that which one of the following is generally used in domestic refrigerator? Air cooled condenser, water cooled condenser, evaporative condenser, air cooled or water cooled condenser. So in our domestic refrigerator, home refrigerator, we use air cooled condenser is there. So option A is correct. Now what is used in an evaporative condenser as a cooling medium? Air only, water only, air and water both, neither air or nor water. So in evaporative condenser we know that water and air we both require, so option C is correct. Next is the effectiveness of cooling tower depends upon dry bulb temperature of the air, wet bulb temperature of the air, direction of flow of the air, none of the above. So its answer is B, wet bulb temperature. The fin type condenser in a household refrigerator is located at edge of the refrigerator, top, side, bottom, back. The condenser is always used in back side of the refrigerator, so the option D is correct. It is used back side. The condenser fins of refrigerators should be cleaned by painting brush, soap solution, diluted acid, pin comb. So its correct answer is painting brush. So these all we have discussed. In next class we will discuss more about the expansion valve and dryers, some type of expansion valve and dryers. Okay, thanks for watching.